Homework 14, section 7.2, applications of the standard normal distribution, video 4. Let's take a look at one more example. We're staying in the same context as the previous videos, where we have the pregnancy terms being normally distributed with a mean of 272 days and a standard deviation of 9 days. And a pregnancy is considered full term if it's between 252 days and 298 days. And the question is simply, what percent of pregnancies are full term? Well, let's think about this in terms of a probability question. We're being asked, basically, what's the probability that a pregnancy term is between 252 days and 292 days? As a probability question, that would be the probability that 252 is less than or equal to x, which is less than or equal to 298. Visually, that means if we set up the bell curve for the pregnancy distributions, where the mean is 272, then 252 would be to the left of it, and 298 would be to the right of it. And if we draw vertical lines up from 252 and 298 up to the curve, then the percent that we're looking for is going to equal the area between those two. Area between x equals 252 and x equals 298. But our z-table does us no good because this is not a standard normal distribution. The middle isn't 0, standard deviation isn't 1. But we can convert it. By the way, when you convert a problem from x to z, it's called standardizing a probability, or standardizing a distribution. So we need to figure out the z-scores that correlate to the x scores over here. Remember, these are x's, these are z's. And once we find those z-scores, then we can use our z-table. I'll remind you how to find the area between two z's in a moment. Apologies, the middle of this should be 0, not z. So we have to do two conversions. Let's start with the 252. For 252, to calculate its z-score, it would be 252 minus the mean, 272, divided by the standard deviation, which is 9. That's equal to negative 20 over 9, which is approximately negative 2.22. Let me make sure that's right. Yes, negative 2.22. But for the for the x on the right side of the shaded area, to calculate its z, it would be 298 minus the mean, 272, divided by the standard deviation, which is 9. The difference in those is a lot. It's 26, isn't it? Yes. 26 divided by 9. And if you divide that out, it's going to be about 2.89. So that means that the corresponding z-scores in the standard normal distribution are negative 2.22, z equals, and z equals 2.89. Which means the corresponding probability question is the probability that negative 2.22 is less than or equal to z, which is less than or equal to 2.89. And now we have a z problem, and hence our z-table can be used to solve it. But do you remember how to find the area between two z-tables when all your two z values, when all your z-table tells you is the area to the left of something? And the answer is, look up both areas and subtract them. When you look up the area to the left of z equals 2.89, you get everything over here, including this part we don't want. When you look up the area to the left of negative 2.22, it tells you the area of the part we don't want. So it's the total area to the left of this z minus the area we don't want to the left of that z. So we just look them up and subtract them. Now, the rightmost z will have the greater left area, so it will be the one that you should look up first. Well, you can look them up in any order, but when it comes time to subtract them, make sure you do the greater one minus the lesser one. Now, using my z-table, the area to the left of 2.89 is 0.9981. And using my z-table, the area to the left of negative 2.22 is 0.132. 0.132. No, 0.0132, excuse me. So, use the z-table to find the left area, and use the z-table to find the left area, and then you just subtract them. I think I can do this without a calculator. 11 minus 2 is 9, had to borrow. 7 minus 3 is 4. 9 minus 1 is 8. 9 minus 0 is 9. So it looks like our probability is 0.9849, but since the question was what percent of pregnancies are full term, it would be better to turn this into a percent. 98.49% of all pregnancies